Are there resources missing in the Azure RM provider? Are there features you want to implement that just aren't there? Do you find yourself using ARM templates instead of Terraform? Well, I've got an alternative for you. Today, we're going to explore the AzAPI provider. Hey, what's up, everybody? It's Ned Bellavance, Ned1313 on Twitter, and welcome to Terraform Tuesday. Today's topic is the AzAPI provider, what it is, what it's used for, and sort of the functionality inside of it. So we're going to explore all of the components of the provider. Before we get into that, two quick things. Number one, I just published a 5-part live project path or bundle or whatever you want to call it on manning. So I'll include the link down below. It is managing an AKS cluster using Terraform. So you use Terraform to build up the AKS cluster. You'll use that in conjunction with Azure DevOps to do some management of that cluster. You'll set up monitoring, you'll secure the cluster, all using Terraform. It's a pretty cool set of live projects, so if that's of interest to you, check out the link down in the description. The other thing I want to mention is if you're watching this before October 2022, I will be attending and speaking at HashiCorp Global in LA. So if you're going to be in the area or you don't mind a little bit of travel, consider the conference. I think it's going to be a really good time. All right, with that out of the way, let's focus in on the AzAPI and what it's for. You know, one of the things that I often get asked when I'm doing Terraform training is, what if there's a service that gets introduced in one of the clouds, but it's not yet in the provider? What can I do? What are my options? Because maybe I want to stay on the bleeding edge, or this new service got introduced that I really want to implement, but I want to stay in the ecosystem of Terraform. What can I do about that? Now, in terms of Azure and the Azure RM provider, you used to have a couple options and none of them were great. For starters, the provider is open source. It's maintained by HashiCorp and some folks at Microsoft, but it is open source and open to contributions. So if you wanted to, you could write your own resource or update an existing resource with the new features. But I acknowledge that not everybody out there is a Go developer, so you might want to consider another option. And that other option was to make use of the ARM template resources in the Azure RM provider. So what those resources would do is either deploy a template at the resource group level, at the subscription level, or even at the management group level. So that might seem like a good option because anything that's been launched and is available through the Azure Resource Manager API is also intrinsically supported by their ARM templates. So that gives you that one-to-one parity you're looking for and lets you keep leveraging Terraform. The downside to that is Terraform's only aware of the properties of the actual template that gets deployed, not the status of the resources inside of the template. So you're managing a template deployment, not the resources that template deployment deploys. So that might sound a little confusing, but the upshot of it is you're not truly managing the resources with Terraform, you're managing the thing that's managing the resources. So if you didn't like either of those options, well, you could move outside of Terraform and do something completely outside by scripting something out or making it a separate part of your workflow. But recently, Microsoft introduced a new provider called the AzAPI provider, and it is meant to help with these shortcomings when it comes to using the Azure RM provider. So let's explore the AzAPI provider. So what is the AzAPI provider and how is it different than the Azure RM provider? Well, the main thing that the AzAPI provider is a very thin shim over the Azure Resource Manager API. You're basically sending HTTP requests in a slightly abstracted format to the API, and then getting back the response from that API, and then turning that into outputs and attributes you can use in the rest of your Terraform configuration. So it's very thin. It doesn't have a whole bunch of specific arguments around that resource. So in a way, the resources inside of the AzAPI provider are not fully fleshed out resources like in the Azure RM provider. They're just that thin sort of shim. And you'll see what I mean in a moment when we walk through an example of actually using one. The other big difference is in the AzAPI provider, there are only 3 resource types and 2 data source types, and that's it. So there's not a ton going on in that provider, but it is really meant to fill in the gaps. So what are the 3 resource types and the 2 data source types? Let's go over those briefly, and then we'll dig into an example of using some of these in an actual implementation. So the first one is the AzAPI underscore resource. And this is a very simple shim that allows you to create an object in Azure. And you would typically use this when that same object does not yet exist in the Azure RM provider. That could be because it was recently introduced and they just haven't had a chance to add it, or it could be something that's in preview that might never make it to GA, and those generally don't get added to the Azure RM provider. But you can use either of those with the AzAPI resource. So you can create resources in Azure using that. You can also update the properties of existing resources that you're managing with the Azure RM provider, but maybe there's a feature that was added in preview or was added in the regular product that just hasn't made its way to the latest version of the Azure RM provider. If that's the case, you can still provision that object with the Azure RM provider and then use the AzAPI update resource type to apply those additional features, that additional configuration information. So that's 2 of the resource types. The third one was recently introduced, and it's the AzAPI resource action. And what this does is allow you to send an actionable command against the target resource that will in some way modify that resource. So it could be sending a run command or a start command to like Azure Automate or something like that. I don't love this resource type because in a way it sort of breaks the declarative nature of Terraform because you're issuing an imperative action. So I don't love it. But I also understand why some people might want it, and I actually use it in the configuration we're going to see in a little bit. So it's there. The 2 data sources that exist, one is the AzAPI resource data source type, which allows you to reference an object and get information about it, just like any typical data source. And the other one is the AzAPI resource action. And this is sort of the read-only version of the AzAPI resource action resource type. So instead of modifying the target object, it just collects information about it. So an example would be you running list keys against an Azure automation account to get the key, enumerate the keys that are in it. So that might be a data action that you want to perform against that object, and there's no existing data source in the Azure RM provider that allows you to do exactly that. So those are the 3 resource types and the 2 data source types. Why don't we get into an actual example so you can see how you might implement this in the real world? Okay, for my example, we are going to be looking in the directory 2022-0517, so you can kind of tell when I started writing this, AzAPI. If you're looking for these files, you can always find them on my GitHub account in the repository Terraform Tuesdays. The link is always in the description if you're looking for it. I'm going to go ahead and expand this one, and there's 2 examples in here. One is an example of image builder, and the other one is an example of a storage account. So the storage account shows you how you would use the AzAPI update resource type, but we're going to focus on image builder. Now, why did I write this configuration? I was working on an Azure Virtual Desktop project, and I wanted to automate the creation of custom images for those virtual desktops using Terraform. And at the time, and I think still currently, there was no image template resource type that I could use. So knowing that, and also knowing this AzAPI thing just came out, I decided that I would take advantage of the of that template object by using the AzAPI resource type. So let's take a look at what is actually in there, and we'll take a look at main. And why don't we just start at the top so I can point a few things out. I'm mixing and matching both the Azure RM provider and the AzAPI provider. I'm starting by creating a resource group and then a user assigned identity. and a role definition. So this is the identity and the role that will allow Terraform, or at least the process for image builder, to build these custom images. Scrolling down a little bit more, I assign the role that I just created to the user identity that I created, and then I create an Azure Compute gallery that is going to store my images and create an gallery image definition. So far, so good. I'm using the Azure RM provider for all of these. But then we get to the actual image template that runs against Azure Image Builder to create the image that will then be stored in this image definition. And so for that object didn't exist in Azure RM. So instead, I'm using the AzAPI provider. So let's take a look at the format of this resource. So the type is AzAPI resource, right? And I give it the name image templates because I'm building an image template. The first argument here is the type. And the type is going to be a mashup of the object type according to the API, and then an @ symbol, and then which API specific, which version of the API you're referencing, because there are different published versions of the Azure RM API. The next one is the name of this object. So I do have to give it a name, which will be used in the deployment of it in Azure. The parent ID is usually going to be a reference to the resource group where this object is going to be created. The location should be self-explanatory. You can set depends on if you need to. You can also give it a user assigned identity. So an identity block is supported by this resource type, and of course tags are supported. But then we get down to the weird part, which is this argument called body. And if you recall earlier, I said the AzAPI is just this thin shim over the Azure Resource Manager API. This body argument is the body of the request that gets sent to the Azure Resource Manager API, along with the specific type of resource that you're trying to create or manage. So within this body, we need to give it a JSON payload. So we're going to use the JSON encode function to take what is in HCL syntax, basically, and turn that into a JSON payload that gets delivered in the HTTP request. And the properties in here are going to be the properties of the resource that we're creating. So I'm not going to go through all of the properties here, but just to give you an idea, because we're creating an image, we have to give it some information about the build, the VM we're going to build it on. So what's the VM size of that build, OS disk size, what's the source image that you're building this custom image off of, and then some customized statements. How do you want to customize this image once the virtual machine has been booted up? And then the distribute area defines how the image should be distributed out. In this case, we're using a compute gallery to distribute our image. So there's some information that goes in there. Now, I'll talk in a moment about how I actually got all of these properties because they're not obvious, right? But this body gets turned into JSON and submitted as part of the request. Now, I do have a lifecycle block down at the bottom that says ignore any changes to the body. And that's because specifically with some of the properties inside of it, those get altered once the object has actually been created. And in a typical Azure RM resource, it would know that some of these attributes can be safely ignored. But the AzAPI doesn't always know that, so it might try to continually update this resource because the properties have changed. That's fine. That's why I had to put the lifecycle block in there for the body argument specifically. Now, once the image is actually built, or once the image template exists, to create the image itself, I have to run Image Builder. And before I was doing that with a PowerShell command. But hey, I don't have to do that anymore because there's now this AzAPI resource action. So I can specify the type, which is going to be a similar type, Microsoft Virtual Machine Images image template, the resource ID that I want to run this action against, the action that I actually want to run, and I found this action from a PowerShell command that was invoking an ARM action, I think was the PowerShell command or something along those lines. I looked at the action and it was run. I was like, oh, okay, because this wasn't well documented, unfortunately. And then the response export values are what values from the response you get back from the HTTP request. Which of those values do you want to export? In this case, I just said, give me them all. I'll interpret them as output later. I also made it optional. So there's a count argument here that looks at a variable, build image. And if build image is set to true, it will run this action. And if it's set to false, it will not run this action. The build process can take 30, 45, 50 minutes, depending on the image. The default timeout is 30 minutes. So I added a timeout for create of 60 minutes so that this would not time out in practice. So let's go ahead and run this. And for beginner, we're just going to create everything, but not run the actual build process. So let me pull up the terminal here. I'm already in the image builder directory. We'll do a Terraform validate just to make sure I didn't screw anything up when I was putting some polishing touches on it. Okay, that looks good. And we'll do a Terraform plan and go ahead and run that. And it should tell me all the resources that it's going to create. And then once the Terraform plan is complete, I will run a Terraform apply with auto approve. Now, building out all this will take a little bit of time. So once I kick off the apply, we'll jump to when it finishes its initial apply and take a look at how things are in the portal. So let's give it a second to finish the plan, and then I'll run the apply, and then we'll see the resources that are generated in the Azure portal. All right, I'm going to run Terraform apply with the auto approve. And that is probably going to take 10 minutes or so. So I'm going to let that run in the background and we'll jump to when it has completed the command. All right, our deployment has completed successfully. We've got our resource group created, our template. Let's jump over to the Azure portal to just get a visual cue on what's going on. Jump over to that. All right, here is the Azure portal, and looking at the screen, we've got our VM image definition, we've got a managed identity, we've got an image template, and an Azure Compute Gallery. So we got all the things that we need to successfully build the image, but if we take a look at the image template, this is what actually gets executed to build the image using Azure Image Builder. And right now, it has not been run at all. So build state is nothing, build message is nothing. So let's go back to Terraform and we're going to update the variable that actually runs the build. Back in the Terraform configuration, the variable that controls whether or not the build image resource action is created is build_image. And I'm going to set that to true. So we'll do a Terraform apply. And we're going to add a variable in here, and I'm going to set build_image equal to true. Close that out. And now it should update it that it's going to create one new resource, and that new resource is going to run the build image process for our template. So let's give this a second to prompt me to accept the application. And once I say yes, we can switch back to the portal and we'll see that the build process has actually kicked off for our image template. All right, so I've responded yes to the prompt. Let's go back to the portal and I'll refresh the view here. And now you can see build run state is running building. Now, like I mentioned, this can take 35, 40 minutes, depending on the image that you're customizing. I'm not going to wait around for that to finish. But you can see that the action did what it was supposed to. It kicked off the run. So if you did want to have a usable image at the end of all of this, when you did your Terraform apply, including the run action in there will allow you to do that. And then you could even make use of that image somewhere else in your configuration to build out your Azure virtual desktops or however you're using the image builder. Two big questions I get for people who are using the AzAPI provider is one, where do I get all of this information from to put in the body? Because it's not obvious at all. Normally you would go to the Terraform provider documentation, you look at the resource, you look at the arguments for that resource, and boom, there you go. the AZ API provider doesn't really work that way. So let's address that question first. And I'm going to point you at a documentation site for Microsoft, and I'll include it in the description as well. This is the Azure templates documentation for defining resources with bicep, ARM templates, and the Terraform AZ API provider. So there you go. That's if you want to use the AZ API provider, awesome. All you have to do is go here, and the column on the left has all the different resource types that you might want to manage. And then you can go into any of these. Let's pick one at random here. Let's say CDN, and I want to manage CDN profiles. And then there's tabs across the top. I can select Terraform, and it will give me an example of how you can use the AZ API provider to manage this object type, as well as giving me a full list of all of the property values that would go in that body argument. So if you are trying to find the proper documentation, that's where you'll go to find it. I'll also say a nice shortcut for me is to go through the deployment process in the UI and generate the ARM template before you actually deploy the resources. And then that ARM template will have not only the properties, but the proper values associated with it as well. So that's a nice shortcut if you need it. The other question I often get asked is, well, what happens when my object type or the feature gets added to the Azure RM provider and I no longer need to use the AZ API provider for that object type? And the answer is, fortunately, Microsoft has actually created a tool called AZ API to Azure RM. And essentially what it does is it looks at your current configuration, tries to find matching resources that you're referencing in the AZ API in the Azure RM provider, and then generates a new configuration for you that has those things included. Now, I don't know that it migrates anything in your state from one to the other, so you might still have to do that yourself. I have to take a deeper look at that tool, and that's actually going to be a video in the future where I explore what that tool is capable of and do a migration from one to the other, just to get an idea of how well it works. So stay tuned for that if that's something that you're starting to run into. But that's going to do it for today. We looked at the AZ API provider. We looked at how to use it. We looked at where to get the information if you want to take advantage of it. I want to say to you, thank you for being patient. I know the videos have been a little slow lately, and that's because I've been ridiculously busy on other projects. But fortunately, a lot of those projects are now winding down, and I can focus on making some good Terraform Tuesday videos. So thanks for sticking in there. If you happen to come to HashiCorp, definitely come up and say hi. I love meeting people who watch the channel and just hearing more about your experiences with Terraform or just your life in general. That's cool too. Thanks again for watching. Like, subscribe, do all the things, and I will see you again real soon. Now, if you do happen to come to HashiCorp, I got a 3D printer for my son not that long ago, and I started 3D printing things for myself because, of course, I did. And I made this. It's a little Terraform taco, and I'm going to print out a bunch of these and bring them with me to HashiCorp Global. So if you happen to be there, ask me for a taco, and if I have any left, I'll give you one. All right, take care. Bye now.